Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. In a last session, I think we completed static characteristics of an instrument, right? In that static characteristics, desirable characteristics are over. So, what are the desirable static characteristics that we discussed? Accuracy, resolution, precision, linearity, reproducibility, repeatability, range, spam, sensitivity. These all the things that we discussed in our last session. So these are desirable characteristics, right? So what is meant by desirable? Desirable means sufficient. So definitely each and every instrument should have these type of characteristics. So then only that instrument will give a good result in order to find the unknown quantity, right? Now we'll discuss about undesirable characteristics. Undesirable characteristic means we won't expect these type of characteristics in each and every instrument. Definitely you don't require. So if these characteristics present, definitely the instrument will reach errors and the instrument will get damaged in future. So what are the undesirable characteristics? So those are, you know about undesirable characteristics of hysteresis, dead zone, dead time, threshold, and what you call drift. Now these are the undesirable characteristics of an instrument. We'll discuss each and everything one by one. See, along with my PDF, follow. So definitely you should follow my PDF, right? Then only you will clearly understand, right? The first one is a hysteresis. So what is meant by hysteresis? In each and every time you're calling about hysteresis laws, eddy current laws, what are those? Definitely hysteresis means magnetic reversal. So you have a magnet, right? So when you apply the voltage, the flux will travel in a magnet. I don't know the flux direction, right? It depends on the voltage direction, voltage that you are applied, my flux will travel. So definitely some flux will travel in a straight direction and some flux will travel in a reverse direction. So that flux, for the reversion of that flux, some energy is going to be lost, right? ఇప్పుడు మనం స్ట్రైట్గా నడుచుకుంటూ వెళ్తున్నాం, రైట్? సో when you turned, definitely some energy will lost now. So that's why in a magnet also the flux will lose some energy. So that energy loss we can call it as a hysteresis loss. So clearly understand. It's a simple way. Hysteresis means magnetic locking, magnetic reversal, right? So magnetic reversal means a flux reversal. When start reverse direction, definitely some amount of energy is going to be lost. That loss we can call it as a hysteresis. Now what about hysteresis in the instrument? So I will explain with an example, right? So I have an instrument, I just apply input. So how that input will apply? I'll apply means 0, I'll get the output 0. I'll get input is 2, input is 2, output is 1.8, input is 4, output is 3.8, 6, 4.8, 8, 6.8, 10, 9.8. Along the increasing order, I apply the input. Now, the same instrument, I'm applying decreasing order. First, I'll give a 10. I'll get the result of 9.9. I'll get the 8, 6.9, 4, 4.9. For 6, 4.9, 4, 3.9, 2, 1.9, 0, 0.9. Definitely, that means the same instrument in a reverse direction, the quantity, the output that you are getting is very high when compared to the increasing order. I think you understand, right? Same instrument, input in increasing order will get one type of output, right? Input in decreasing order will get one type of output. So that loss, that deviations, that difference, we can call it as a hysteresis, right? So in any instant, see the definition. If any instrument giving different readings, right? Giving different readings, increasing and decreasing order for a same input, we can call it as a hysteresis characteristic. See once again, if any instrument giving different reading decreasing order for a same input, we can call it as a hysteresis characteristics. The same input that we are applying, increasing order, decreasing order, but my output is different. So that is called hysteresis characteristics. So these type of hysteresis characteristics will exhibit depends on our storage elements. So what are the storage elements? Those are inductance and capacitance. So inductance that can store energy in the form of magnetic field. So that's why definitely you will get these type of losses in the system, right? So definitely you should consider decreasing order only. So when compared to the increasing order, the decreasing order, my output is high in hysteresis characters because some loss is present in the system. Alright, due to that loss, my instrument will reach higher values. Right? So what is meant by hysteresis? Hysteresis means giving different readings. By giving different readings by increasing order or decreasing order of a same input. Right? So that is about hysteresis characteristics. I think you clearly understand what is hysteresis characteristics. Okay. Now we'll go for a dead zone, dead time, threshold. So these definitions are very difficult. By seeing the figure itself, you can define each and every definition. Right? See the figure first. Right? Now the figure is right. So this is the input output with respect to time. Right? This is my input characteristics. This is my input characteristics. And this is my output characteristics. నేను ఇన్స్ట్రుమెంట్కి ఇచ్చాను రైట్. నేను రీడింగ్స్ కలెక్ట్ ఉన్నాను. సో నాకు ఇన్పుట్ ఇలా ఉంది, దాని కరస్పాండింగ్ అవుట్పుట్ ఇలా వచ్చింది. రైట్. ఫస్ట్ డిఫైన్ ద డెడ్ జోన్. Dead zone, that means the minimum time. See, the minimum change in input for which there is no output is called dead zone. I think you people won't understand. See, this is the time na. The minimum time you are changing your input, right? You are changing your input, right? Right. So you don't have any output. So you are changing your input. You don't have any output, right? So this time, this zone, we can call it as a dead zone, right? The maximum change in input, changing input, but you don't have any output. So that zone we can call it as a dead zone. Once again, I'll define the maximum change in input for which there is no output. See, the maximum change in output. ఎక్కడ వరకు the output input maximum change in input for which there is no output. ఇక్కడ వరకు input vary చేస్తున్నావు. Up to now there is no output. So this zone is called dead zone. Dead means don't have any output. Right? The maximum change in input at which there is no output. So that is called a dead zone. Now what is a threshold? Threshold means the minimum point at which, see, so the minimum point at which my output is started. See, the minimum point at which, so see the minimum point at which my output is started, right? So this minimum point, so this is the minimum point now. The minimum point at which my output is started, the minimum point at which my output is started, so that is called a threshold. I think you clearly understand, right? What is a dead zone? What is a dead threshold means? Dead zone means the maximum change. నేను చేంజ్ చేస్తున్న ఇన్పుట్ని, but I don't have any output. So this zone we can call it as a dead zone, right? Threshold means the minimum point at which my output started. So ఈ పాయింట్లో నాకు అవుట్పుట్ స్టార్ట్స్. సో దిస్ వన్ వీ కెన్ కాల్ ఇట్ యాజ్ అ థ్రెషోల్డ్ వాల్యూ. ఐ థింక్ యూ గాట్ ఇట్, రైట్? నౌ డేటెడ్ టైం. డేటెడ్ టైం, సో దట్ మీన్స్ ద మినిమం టైం. డెడ్ జోన్ అక్కడడానికి కావాల్సిన టైంని డేటెడ్ టైం అంటారు. సో డేట్ టైం మీన్స్ ద టైం రిక్వైర్డ్ for a given input my output is started. So this time This time we can call it as C. So this time we can call it as a dead time. డెడ్ జూన్ రావడానికి అవసరమైన టైంని డెడ్ టైం అంటారు. సో దట్ మీన్స్ ఎక్కడైతే ఇచ్చిన ఇన్పుట్కి మై అవుట్పుట్ స్టార్ట్ అవుతుందో అప్పటి వరకు టైంనే డెడ్ టైం అంటారు. సో దిస్ ఈజ్ ద టైమ్ యాక్సిస్నా, రైట్? టైమ్ యాక్సిస్నా నాకు ఎక్కడ అవుట్పుట్ స్టార్ట్ అవుతుంది. సో దిస్ పాయింట్ మై అవుట్పుట్ ఇస్ స్టార్టెడ్. సో దిస్ టైమ్ వీ కెన్ కాల్ ఇట్ యాజ్ ఎ డెడ్ టైమ్. So I can clearly explain one more time. So what is a dead zone? See, so what is a dead zone? So the maximum change in input. So maximum change in input, there is no output. This zone we can call it as a dead zone, right? So what is a threshold? The minimum point. So that means threshold means the minimum point at which my output starts. So this point we can call it as a threshold, right? What is a dead time? The time required for a dead zone we can call it as a dead time, right? So the dead zone time we can call it as a dead time. Dead time means there is no output for changing input. So up to now when my output starts, that time we can call it as a dead time. సో టైమ్ ఈజ్ నథింగ్ బట్ ఎక్స్ యాక్సిస్నా. నేను ఇన్పుట్ అప్లై చేస్తూ ఉన్నా, నాకేమైనా అవుట్పుట్ వస్తుందా? దెర్ ఈజ్ నో అవుట్పుట్. ఎక్కడ అవుట్పుట్ స్టార్ట్ అయింది? థ్రెషోల్డ్ దగ్గర స్టార్ట్ అయింది నా అవుట్పుట్. సో దిస్ టైమ్ వీ కెన్ కాల్ ఇట్ యాజ్ ఎ డెడ్ టైమ్, రైట్? సో దీస్ ఆర్ ద డెఫినేషన్ ఫర్ డెడ్ జోన్, డెడ్ టైమ్ and all these things, right? Threshold. So what is hysteresis? So we completed hysteresis. What is meant by hysteresis? So hysteresis means increasing order, decreasing order for a same input. My output is changing. So those type of characteristics we can call it as a hysteresis characteristics. What is dead zone? Dead zone means for maximum change in input there is no output. That zone we can call it as a dead zone. What is dead time? Dead time means, what is threshold? Threshold means the minimum point at which my output starts. That time is that point we can call it as a threshold. Dead time means that zone time is nothing but dead time. Dead time means for a changing input there is no output. So that time we can call it as a dead time. So up to where my output starts, right? I think you clearly understand dead zone. What is dead zone? What is dead time and threshold, right? Now there is one important point. Dead zone, threshold, both are input values. See here, dead zone, this is a zone na, this is input na. Threshold, this is a input na, input lone undi kada adi kuda. So my dead time is the only time, remaining all are input values. This is a get question. So dead zone, threshold, both are input values. Dead time is a time value, right? So it's not required once again, right? So definitely you should understand. Okay, now we'll start. What is a drift? What is meant by drift? Drift is nothing but deviation from input to output. The deviation from input to output. Actually ఎక్కడ డ్రిఫ్ట్ వస్తుందంటే యాక్చువల్లీ నల్ పాయింట్ ఎక్కడి నుంచి స్టార్ట్ అవ్వాలి? పాయింటర్ జీరో నుంచి స్టార్ట్ అవ్వాలి. బట్ సమ్ ఆఫ్ ద ఎక్స్పెరిమెంట్, సమ్ ఆఫ్ ద ఇన్స్ట్రుమెంట్, మై పాయింటర్ ఓన్ స్టార్ట్స్ ఫ్రమ్ జీరో కంటే ముందు పడిపోయి ఉంటుంది. సో దట్ వీ కెన్ కాల్ ఇట్ యాజ్ ఎ డ్రిఫ్ట్ డ్యూ టు పాయింటర్ నాట్ స్టార్ట్స్ ఫ్రమ్ జీరో, రైట్? సో డ్రిఫ్ట్ అవాయిడ్ చేయాలంటే డెఫినెట్లీ యూ షుడ్ మేక్ దట్ పాయింట్ ఎట్ జీరో పొజిషన్, right? Drift is nothing but deviation from output to input. So first is a zero drift. Zero drift means throughout my measurement this drift is constant. So this is right. So this is input and output for system. This is my input. Drift valna you are getting the output like this, right? This is called a drift. So this is called a drift. జీరో ఉందనుకో, మనకి యాక్చువల్గా జీరో ఉండాలి, ఇన్పుట్ జీరో ఉన్నప్పుడు అవుట్పుట్ కూడా జీరో ఉండాలి. but due to the drift, output has some value. So through the measurement, my drift is constant, so that we can call it as a zero drift. So zero drift ఎందుకు వస్తుంది? Pointer not starts from zero. You have to adjust that pointer and make that pointer at zero position, right? After that, span drift. Second one is a span drift, right? Throughout the measurement, my drift starts increasing. So see, throughout the measurement, this is my input, normal characteristics, right? నేను ఎక్స్పెరిమెంట్ చేస్తున్నా, ఈ డ్రిఫ్ట్ అనేది ఏమవుతూ ఉంటుంది, అవుట్పుట్ increases. That means throughout my measurement, my drift starts increasing. So that is called span drift. It can be developed, it can be because of external field, whatever the field that you are applying. That means either magnetic field, static field. Due to that, drift goes on increasing. Alright. After that, zonal drift. Zonal drift means up to some portion only my drift start increasing. After that, normal value. See the figure. So this is input, output, this is a time. So up to, this is a normal characteristics. Up to some portion I have a drift. After that, normal. So that is called particular zone value. But up to particular zone, my drift is, there is a drift. After that, there is no drift, normal characteristics. So that is called a zonal drift. See once again, what is a drift? A drift is nothing but a deviation from input to output. We can call it as a drift. So drift ఎందుకు వస్తుంది? Definitely my pointer will start from zero position, but due to some external condition, my pointer won't start from zero. Pointer పడిపోతుంది. So you should make that pointer like position, then start the experiment. So if you don't do this, definitely the drift will be present. Throughout my measurement, drift is constant. That means input to output difference is constant, then we can call it as a zero drift. After that, what is a span drift? Span drift means throughout my measurement, my drift start increasing order. So it can be done due to the external field. So what is a zonal drift? A zonal drift is a particular zone, particular point, my drift is there, and drift start increasing. After that, there is no drift in the instrument. So this is undesirable characteristics. Definitely, if a pointer 0 కంటే తక్కువ స్టార్ట్ ఉందంటే definitely you don't require those type of, that will reads an error. So that is undesirable. So that's why we can call it as a drift is undesirable static characteristics for an instrument. Right? After that, so these are the undesirable characteristics. So what are the